Welcome back, and today we are going to learn something a little bit new. It's called the number E, and this is Euler's number. It's the natural exponential. It's an irrational number like pi. So everybody has their graphing calculator on their desktop. So if we were to press E, that's going to be the second button, and then the LN button. It's going to give you E. It's going to give you E to the X. So if you put in E to the first power, you always have to put in some type of exponent when you're using the calculator. You're going to get the number up here, which is 2.7182818284, blah, 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 blah. Okay, so we're going to start out by just working with our graphing calculators and evaluating E to the second. So remember, you're going to hit the second button, and then there's a button on the left side. That's an L and an N. So second, LN, and E with an exponent should pop up. Put in a 2, and you should get approximately 7.389. Let's go ahead and round to the thousandth. When you get to your homework, just do what they ask. All right, so now try 3 times E to the negative fourth power. 3 times E to the negative fourth power on your calculator. Now check while I'm doing this, you should get approximately 0.055. Don't forget, you have to use your negative sign at the very bottom. You can't use the minus sign for that. And last but not least, 0.25 times E to the sixth. Do that on your calculator, and you should get approximately 100.857. Okay, make sure you are asking us questions if you are having problems with any of this. Okay, so the nice part, this is all review here, is that we are going to simplify by using properties of exponents. Excuse me. So, first of all, we have 4e to the 3x, quantity squared. Who gets the power of 2? Well, both of them do. So the 2 is going to go to the 4. So that's going to give us 4 squared. And then it goes to the e to the 3x. And what happens when you have an exponent to an exponent? Well, you multiply them. So it's going to be 3x times 2. So your handy-dandy answer is going to be 16. E to the 6x power, and we are finished. Not too bad. All right, next we have the square root of 9e to the 10th power. First of all, take the square root of 9. What is the square root of 9? The square root of 9 is 3. And we can do a shortcut here. Remember, there is a 2 here for square root. How many times will 2 go into that 10 power? That's going to be e to the 5th. Woohoo! See, it's a little bit different, but we're still using the same properties. Next, the cube root of 8 is 2, because 2 times 2 times 2 is 8. And then we have, how many times will 3 go into 9x? 3 goes into 9x, 3x times. And that is our answer. Not too bad. We have a couple more that we're going to do like this. All right, now we have the same base being multiplied. So if the bases are the same, what do we do to the exponents? Well, we add them. So we have e to the 4x plus 6x, which gives us an answer of e to the 10x. All right, this next one looks a little bit more difficult, but it's not. So what we're going to do is we're going to start out with a fraction. And these numbers in front, I use them just like a fraction. We're going to reduce them. What is the largest number that will go into both 20 and 35? Well, that's 5. We're just reducing that fraction. 5 goes into 20 4 times. 5 goes into 35 7 times. Next, if I am dividing, what am I going to do to my exponents? I'm going to subtract them. So that's going to give me e. What is 7x minus x? Well, I can write it as 4e to the 6x all over 7, or I can have 4/7 times e to the 6x. All right, any questions? Make sure you get in contact with your teacher. So let's continue. All right, so how do we decide if the natural e function is an exponential growth or decay? Abigail, hush. My puppy does not like others walking down the street, so she has to bark at them. They're almost gone. Okay. So the way that we find out if the natural e function is a growth or decay is I have this value right here. Is that b value greater than or less than 1? Well, e to the first power is 2.7 approximately. So we are going to look at a growth on this one. And you know that because your exponent is positive. All right, let's look at the next one. Well, my base, Miss Bybee, it's still e. Oh, but remember, can we ever have a negative exponent? No, so this is actually written as 1 over e to the x. And 1 over e is going to be less than 1. So this one is a decay. So when we get to some problems, if we have e as our base, look at the exponent. If it's positive, it's going to be a growth. If it's negative, it's going to be a decay. All right, here we go. We are going to look at these graphs. We got to decide whether it's an exponential growth or decay. So since my base is e, we look at our exponent. Is it positive or negative? It is positive, so it's going to be an exponential growth. Okay, now you're just going to have to decide out of 4 choices which one is the graph. We're going to do a little bit of graphing here that you're not going to have to, but it will help you in deciding which one is the correct graph. So to do that, I'm going to make an XY chart. Love the XY charts. So if I put in a -1, that's going to give me e to the -2. So on your handy dandy calculator, you're going to push in e to the -2 power, and you're going to get approximately 0.14. So my first point is -1, 0.14, so it's really close here. Next, let's put in a 0. e to the 2 times 0 is 0, and we don't have to put that one in the calculator because anything to the 0 power is 1. So 0, 1. Next, let's put in a 1. So e to the 2 times 1 is e to the second. E to the second power is approximately 7.4. So 1, 2, 3, 4, 5, 6, 7.4. Don't forget, exponentials have an asymptote at y equals 0. So this is what our function looks like. Now, let's go back and look at some of the values. Remember, with y equals ab to the x, this a is our initial value. Okay, so your first point is going to be 0a. But on the one that we had y equals e to the 2x. My a value was just a 1. So that's why it's at 0, 1. So that initial value should help you with your graph. Let's do another one. Okay, decide whether this next one is an exponential growth or decay. Ooh, looking at this right here, it is negative, which means this graph is going to be a decay. All right, so XY chart, because you're going to have to pick out the graph, and hopefully after doing a few of these, we can just pick it out and not have to do an XY chart. I'm going to put in -1, 0, and 1 again. So I'm looking at 3 times e to the -1. What's a -1? Well, that is a +1. So on your calculator, you're going to put 3 times e, and do we have to put the 1? Yes, we do on the calculator. And we get 8.2. So -1, 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. Okay, next we're going to put in a 0. 3e to the 0. Well, e to the 0 is 1, so your answer should come out to be 0, 3. This is your initial value, and I see it right here. Initial value right there. It's going to cross. Okay, and our last one. 3e to the negative, and I'm going to put in a 1. So on your calculator, 3 times e to the -1. Don't forget to use the negative button and not the minus button. And we get 1.1. 1.1. So we're going to have a decay. And don't forget, what is our asymptote? Our asymptote on this one is y equals 0. How's it going, guys? Feeling good? Okay. This is our last one before our assignment. Okay, what's different about this one? Well, first of all, we have something new, a -1. So, let's do an XY chart. Is this going to be a growth or a decay? Well, it's going to be a growth because this value is positive. It's going to be a growth. All right, so let's plug in -1, 0, and 1. So 4 e to the -1 minus 1 gives us 0.5. Okay. Next we have 4 times e to the 0. Well, e to the 0 is 1. 1 times 4 is 4. 4 minus 1 is 3. 0, 3. And then if I put in a 1, 4 times e to the first minus 1, and don't forget, you do have to put in that first, and you get 9.9. Okay, I still can't see everything I need for this graph. So I'm going to put in a -2. -2. So here we go. And I get -0.5. That's a little bit different because where is our asymptote normally? Our asymptote is normally at y equals 0, but since this whole thing shifted down 1, my asymptote is going to be sitting at y equals -1. So to graph this, it gets very, very close, and then it goes very fast. Very fast. So there is the graph, and you can graph this on your graphing calculator. What's the domain? I can put in any value for x. It goes to the left forever, goes to the right forever, so it's going to be -infinity to infinity or all real numbers. Your range, since my asymptote went down 1, it's going to start at -1 and go to infinity. So what is your y-intercept? Your y-intercept occurs when x is 0. So your y-intercept is 0, 3. Now the x-intercept is going to be more difficult on a question like this because you will need to graph it in your graphing calculator. So graphing calculator, we have 4 e to the x minus 1. And then for my y2, this is going to be y1. Y2, I'm going to make 0 because I want the intersection. Remember, for intersect, you do second, trace, 5. Get it close. Enter 3 times. And you get -1.386. Okay, your asymptote we already have, y equals -1. All right, now let's talk about f approaches blank as x goes to infinity. So as x goes to infinity, what is my y value doing? It's going to positive infinity. F approaches blank as x approaches negative infinity. As my graph goes to negative infinity, what number is it getting closer and closer and closer to? Yep, it is -1. This is how Big Ideas does this problem that I assigned you, so that's why I put it in the notes that way. All right, here's your assignment, 6.2a. Any questions, contact your teacher at their office hours. Have a good evening.